These are the video notes for section 7.7, solving rational equations. We have 3 steps: factor the denominator if possible, multiply the entire equation by the LCD, and then finally solve. So if we take a look at our first example, the LCD between the denominators x plus 4 and x minus 3 would be x plus 4 times x minus 3. So what we're going to do is we're going to take the LCD and multiply the entire equation by it. The reason why we're multiplying by the LCD is actually to clear the fraction, and you will see that happening when we do the side work for this. So I'm going to take the least common denominator and put it over 1. And I'm going to multiply it by 5 over x plus 4. I'm going to do the same thing and then multiply it by 2 over x minus 3. In our first example, when I simplify, the x plus 4 is divided out, and I'm left with 5x minus 15 when I distribute the 5 to the binomial. In this one, the x minus 3 is divided out, and I will be left with 2x plus 8. So when we multiply the LCD by the first fraction, it turns into 5x minus 15. We're going to bring down the equal sign, and the second fraction turns into 2x plus 8. And now we have an equation that we can solve without the fractions being there. So we're going to subtract 2x on both sides, and then add 15 on both sides. So we have 3x is equal to 23. Divide both sides by 3, and then we will get x equals 23 over 3. In our next example, we have 3 fractions, so we need to find the LCD for all 3 fractions. So the LCD here would be 15r. Then we're going to do the side work to figure out what each one will turn into. Take the common denominator and put it over 1. Then multiply by each part. Now we're going to simplify. 3 goes into 15 5 times. The r is divided out. When I distribute the 5, I'll get 5r minus 20. In this next example, 5 goes into 15 3 times. The r is divided out. And we are left with 6. And then this one, 5 goes into 15 3 times, and we get 3r. So now we're going to rewrite the fractional equation, and we will get 5r minus 20 plus 6 equals 3r. And then we can solve the multi-step equation. We're going to combine our like terms, subtract 3r on both sides, add 14 on both sides. We get 2r equals 14. Divide both sides by 2. Finally, r equals 7. In our next example, we're going to factor the denominator, 3x minus 4, to help us find the LCD. The LCD in this example would be 3 times x minus 4. Then we're going to multiply the LCD by each of the fractions, so we're going to set up the side work. The first one, the 3 is divided out, and we're left with 4x minus 16. In the second one, the x minus 4 is divided out. We're left with 21. And this divides out with that, and we are left with x minus 1. So when we rewrite the fractions, 4/3 becomes 4x minus 16. The second fraction becomes 21. And the last fraction becomes x minus 1. And then we can solve the equation. We combine our like terms. Subtract x on both sides, subtract 5 on both sides. We get 3x is equal to negative 6. Divide both sides by 3, and we will get x is equal to negative 2. In our next example, we're going to factor the difference of perfect square to a plus 1, a minus 1. Then we're going to multiply everything by the LCD, which is a minus 1 and a plus 1. We're going to set up our side work. The a minus 1's divide out, I'm left with 2a plus 2. The a plus 1's divide out, I'm left with 5a minus 5. And this denominator divides out with this numerator, and we get negative 6. So when we replace all the fractions, we get 2a plus 2 plus 5a minus 5 equals negative 6. Then we're going to combine our like terms, add 3 on both sides, divide both sides by 7, and a is equal to negative 3/7. In our last example, we're going to multiply by the LCD, which is x minus 5 times x plus 11. So we're going to set up our side work. The x minus 5's divide out, and we're left with x squared plus 11x. Then the x plus 11's divide out, we're left with 3x minus 15. So we're going to replace the fractions with x squared plus 11x equals 3x minus 15. If you notice, for this equation here, we're left with an x squared, so we know we have a quadratic equation that we have to solve. So we're going to bring everything to one side. Subtract 3x plus 15. So I have x squared plus 8x plus 15 on the left side equals 0. Then we're going to factor the basic trinomial to x plus 5, x plus 3 equals 0. We're going to take each of the binomials, set them equal to 0. Solve for x equals negative 5, and x equals negative 3. So we have two solutions because we ended up with a quadratic equation.